Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student. So the question has to do with throwing an object off the top of the building, and they're giving us an XY table here for half a second, 1 second, 1.5 seconds, 2 seconds, 2.5 seconds, 3 seconds, and these are the heights here. And they're asking us to fit a regression equation to this data set. So I chose to do this in Desmos because it's the most convenient way for me to present the result. Of course, you can do this on your graphing calculator. If you don't already know Desmos, I would suggest you get to know it. It's a very useful tool, very easy to use. And if you're taking a PSAT this year, this coming October 2023, you'll have access to Desmos online when you're taking the PSAT. And if you decide to take an SAT after that, Desmos will be available to you online starting in March of next year, 2024. So it's a tool that's worth knowing. Okay, so I just took these data points and I put them into Desmos. You can see that they're just organized in a table. And you can also see that if you just look at the data points, it's obvious that this is quadratic equation. So I typed in a general purpose quadratic equation here, and it came back with a perfect fit. R squared equals 1 tells me it's a perfect fit, but my I also tells me it's a perfect fit, so there's really no question about whether I chose the right model. Linear wouldn't work as well, and so on. And now it's giving me the coefficients of the regression equation down here. So I'm going to write that down here. So this is going to be y. Well, let's use our the variables as given. H of t is going to be negative 4.9 t squared plus 27.9 t plus 66. So you can see from down here, these are the values that the Desmos product that Desmos produced, and now they want to know H of 2.6, and you would just plug that in. And when you do all of that, again, you would do this on your calculator, you should get an answer of 105.4 meters. And that's all there is to it. Now, if you look at 2.6 on the graph, it's roughly here. And if we just put a dot here, a hash mark here, that's roughly 2.6. It's not exactly 2.6. And if we just travel up to here, we get this point here, and you can see this is 90, and then 1, 2, 3, 4, so it's 25 each jump. So this would be 50 here, 150 here. So you can see our answer would be a little above. Let's see. I think I have that. Sorry, I think I have this wrong. Just erase that. I just wasn't reading it well. It's hard for me to read, so it's probably even harder for you to read. Yeah, this is 110 here. So 1, 2, 3, 4. Yeah, it's 2.4. So this would be 100.5 here. Oh no, this would be 105 here. Sorry, 105. And you can see this point here is roughly 105. This is, this is 125 here. Yeah, anyway, that's the answer. My eyes are going crossing when I try to do this, but that's the answer when you put it in. Okay, so it's very simple. It's almost all mechanical. Very little thought has to go into it. Just get used to doing this on your graphing calculator or on Desmos. I suppose Desmos wouldn't be allowed in school, so you'll have to figure it out on your Texas Instrument calculator or some other calculator. It's not very hard. On the Texas Instruments calculator, you just go to Stat, and then you would edit and put in your data, and then you go to Stat and then Calc. So to actually get the regression equation after you put the data in, it's Stat. Stat Calc, and then you would choose option 5, which is quadratic regression. So that's how you would do it on your Texas Instrument calculator. Okay, so hopefully that was all helpful to you, and I'll see you again next time. Bye-bye.